Hello everybody, and welcome to my presentation on the research study that I decided to do on the seersucker wood sedge, also known as the woodland sedge seersucker. It is a plant that is pretty common in the area that I grew up, well, not grew up in, I grew up in San Diego, but the area that I live now in Grand Rapids, this has been a very plentiful native plant. So let's just get into it a little bit. There we go. So as for an introduction, this plant is a native plant to North American boreal forests. They thrive in temperate climates and they thrive in partial shade habitat. So what partial shade means is sometimes so the area that I chose was actually right behind my apartment complex. It's like a microforest, but it has a lot of tree canopy and tree cover. So parts of this microforest receives plenty of sun. Some of it gets full shade, some of it gets partial shade. Now this plant enjoys the partial shade habitats where it gets some sun, gets some shade, and it is good to go. What it looks like is, I'll go right back, is that you can see that plant in the very front. It's kind of a long-leafed plant that kind of bunches up in the middle. Kind of looks like an ornamental plant, and that area is actually threatened with being torn down. The area right next to it, about 2 miles out, has been completely destroyed. So I decided to think about that a little bit. With the warming temperatures, if we look into climate change, the warming temperatures, these seersuckers are threatened with full sun. If the tree canopy cannot handle the extra sunlight or the extra warming temperatures. So the seersuckers are prone to curling, which you can see in the first plant on the left, which is like a drying out. They're threatened with desiccation, which is the drying of the leaves, and also burning. It can get hot enough to where the plant's tips can actually burn. If the climate continues to change, a lot of species will need to disperse to the north and south poles, where the temperatures are the temperatures continue to change. If they cannot disperse, they will be subjected to population decreasing or even extirpation. So that is the biggest threat that we see with plants that need partial shade and need those colder climates, and kind of just getting into that, getting into the idea of adapting to these new different climates. For my hypothesis, I decided to go with the differences in climate, one with partial shade and one with full sun. The stream of partial shade will have a higher length of woodland sedge leaves than the hillbank study plot. Now, the first study plot that I chose was the stream. The stream on the left gets partial sun and partial shade throughout the day, so this is like an ideal ideal climate for the seersuckers. And the stream fills up, with storms and drainage, and so this whole area can fill up pretty quickly. The second study site that I chose was the hillbank. This hillbank, as you can see on the left, is pretty. The tree canopy is not nearly as much, so it gets sun throughout the entire day, with only small intervals of shade. Now the picture on the left actually shows a little bit of sage. That was the day it was kind of going into nighttime, so that's not a good representation of the hill. But the hill definitely gets plenty of sun, and it has a better drainage system than the stream, so it can. It might not be able to be a suitable habitat, but we will see the methods. So the methods that I used was I collected 40 samples on each study site. So what I did is I walked a straight line, or as straight as I could, and collected samples as I saw them, not taking too much from one leaf because that could lead to biased results. As you can see on the right, these are all my numbers that I was taken with the study plot for the first one. This is the hillbank. So the hillbank had a sample mean of 30.1. Now if we look into the results, you can kind of see that they're really similar, but the stream had a sample mean of 30.7, which was definitely higher. Not by much, but it was a 0.6 difference in sample size And the sample sizes were taken as the lengths of the leaves that I collected. Now, looking into the discussion, yes, that this was able to prove my hypothesis was correct. There is a higher increase in the woodland seersucker in the stream study plot than the hill bank, but I don't believe that is sufficient evidence, as this is only one experiment, and this experiment might have had sample errors that I didn't see. So there needs to be a lot more experiments done to kind of see what's going on and what habitats are the most suitable for this environment. And these are my references, and I greatly appreciate you guys listening to my research project, and I hope you guys have a great day. Thank you.